Hello everyone, welcome back to my YouTube channel. Myself, Krutika R, studying in Sri Venkateswara College of Engineering in Department of Electronics and Communication. Today I am here to explain you about the role of modulation techniques in wireless communication and its evolution from 1G to 5G. Now let us see overview of the evolution of wireless communication, that is from one generation to five generation. So now let us know about first generation. The first generation is called analog voice. The first generation of mobile communication introduced in the early 1980s. Primarily analog technology offering voice calls with limited capacity. Systems like advanced mobile phone services, AMPS were the earliest examples. Now let's see second generation, that is called digital voice and SMS. It is emerged in the late 1980s and early 1990s. Shifted to digital technology allowing for better voice quality and the introduction of SMS. So SMS meaning is called short message service. Technologies like GSM, Global System for Mobile Communications, and CDMA, code multiple access were prominent. So now let us see about third generation. It's called as mobile data and internet. Rolled out in the early 2000s, enabled faster data transmission, supporting mobile internet access. Introduction of technologies like UMTS, that is Universal Mobile Telecommunication System, and CDMA 2000. So now let us know about fourth generation. It is called as broadband data. Deployed in the late 2000s, provided significant improvements in data speed and capacity, facilitating services like video streaming and LTE. Long-term evolution and WiMAX were the key technologies. Now let us know about fifth generation. So we can also say that it is the leading generation. Ultra-fast connectivity and low latency began deployment in 2020s, designed to offer ultra-fast data speeds, low latency, and massive device connectivity. Utilizes advanced technologies like wave frequencies, massive MIMO. MIMO is nothing but multiple input and networking slicing. Now let us know about the importance of modulation techniques in transmitting data wirelessly. So first one is efficient use of spectrum. Modulation allows for the encoding of information onto carrier signals, enabling the transmission of data over the airwaves. Efficient modulation tactics maximize the utilization of the available frequency spectrum, allowing multiple users and services to share the same bandwidth without interference. Second one, data encoding and multiplexing. Modulation enables the conversion of digital data into analog signals for transmission. Multiplexing techniques like time division multiplexing called TDM, frequency division multiplexing called FDM work in conjunction with modulation to support multiple users on the same channel. Various modulation schemes such as amplitude modulation AM, frequency modulation FM, and PSK, phase shift keying, allow for different ways of encoding data onto carrier waves. Third one, improved signal integrity. By modulating a carrier wave, information can be transmitted more robustly, overcoming challenges like signal attenuation, interference, and noise. Modulation techniques helps in preserving the quality of the transmitted signal, ensuring that the information reaches the receiver accurately. Fourth one, adaptation to channel conditions. Modulation techniques can be dynamically adjusted based on channel conditions. Adaptive modulation, a feature in many modern communication systems, allows systems to switch to a more suitable modulation scheme depending on factors like signal strength and interference, optimizing performance in real time. For example, wideband modulation is suitable for high-speed data transmission, while narrowband modulation may be used for applications with lower data rate requirements. Now let us know about one generation analog modulation. The advent of the first generation of mobile communication marked a significant milestone in the history of wireless technology. One generation system emerged in the early 1980s and represented the first step toward mobile telephony on a wide scale. Unlike modern digital systems, one generation networks relied on analog modulation techniques, primarily amplitude modulation and frequency modulation. While 1G laid the foundation for mobile communication, its limitations paved the way for the development of subsequent generations that would embrace digital technology and advanced modulation schemes, eventually leading to the highly sophisticated networks of today, such as 4G and 5G. The analog to digital modulation marked a critical evolution in the quest for more efficient wireless communication systems. Now let us briefly know about the second generation digital modulation. The transition to digital modulation in the second generation of mobile communication marked a significant advancement over the analog systems of one generation. This shift from analog to digital technology brought about several improvements in terms of signal quality, capacity, and the ability to support data services. Second generation systems were introduced in the late 1980s and early 1990s as an evolution beyond the analog one generation system. Primary motivation was to address the limitations of analog modulation, such as susceptibility to interference, limited capacity, and lack of data services. The transition to digital modulation in second generation set the stage for the rapid evolution of mobile communications and advancements in subsequent generations such as third generation, fourth generation, and fifth generation. Digital modulation became the standard communication, but also a wide range of data services, multimedia applications, and the interconnected wireless networks today. Now let us see about third generation that is called wideband CDMA. CDMA is nothing but code division multiple access and modulation. Wideband code division multiple access is a third generation mobile communication technology that played a significant role in the evolution of wireless networks. It is a standardized technology used for providing high speed data and multimedia services in mobile networks. WCDMA is a part of the family of CDMA, that is co-division multiple access technologies, and it was adapted as the air interference standard for the universal mobile telecommunication system called as UMTS, a 3G mobile communications technology. Quadrature phase shift keying (QPSK) is a digital modulation technique that played a significant role in the development of third generation mobile communication systems. QPSK is a type of phase shift enables transmissions of digital data by varying the phase of the carrier signal. In 3G, QPSK was enhanced the spectral efficiency and improved data transmission capabilities. Now let us know about the fourth generation called LTE, that is nothing but long-term evolution and advanced modulation. Long-term evolution is a standard for wireless broadband communication and represent the fourth generation technology in the evolution of mobile networks. LTE was developed to address the increasing demand for high-speed data transmission, improved spectral efficiency, and advanced multimedia services. It marked a significant advancement over the previous three generation technologies, offering faster data rates, lower latency, and a more efficient use of the radio spectrum. Advanced modulation techniques such as quadrature amplitude modulation are critical components in modern wireless communication systems. QAM is a method used to modulate digital signal to amplitude of two signal waves, usually in quadrature 90 degrees out of phase. Higher order QM and 64 QM are employed to transmit multiple bits per symbol, leading to increased data. Let us see about fifth generation, that is called massive connectivity and wave modulation. 5G, or the fifth generation of wireless communication technology, represents a significant leap forward from its predecessors, that is second generation, third generation, and fourth generation. It is designed to provide faster data rates, lower latency, and increased connectivity to support a wide range of applications and services. Millimeter wave frequencies refer to a range of radio frequencies typically above 24 GHz and extending up to 300 GHz. In the context of wireless communication, wave bands are considered as the integral part of the spectrum that can be utilized for various applications, including 5 generation networks. The use of wave frequencies is a key enabler for achieving higher data rates and enhancing network capacity. The impact of wave frequencies on modulation, particularly with advanced schemes like 256 QAM, that is quadrature amplitude modulation, is significant and transformative. Now let us discuss about the future trends in modulation for sixth generation and beyond. As we look toward future wireless generations beyond fifth generation, several potential modulation techniques are being considered to meet the evolving demands of communication systems. These techniques aim to further increase data rates, enhance spectral efficiency, and address specific challenges associated with emerging applications. Here are some potential modulation techniques for future wireless generations. Those are advanced constellations, sparse code multiple access, that is called as SCMA, sparse signal processing, machine learning, enhanced modulation. Quantum modulation, terahertz communication, full duplex communication, non-orthogonal multiple access, integrated satellite and terrestrial networks, sustainable and energy efficient modulation. It's important to note that the potential modulation techniques for future wireless generations will likely be influenced by a combination of technological advancements, regulatory considerations, and the specific requirements of emerging applications, such as the Internet of Things called IoT, augmented reality, and beyond. Ongoing research and development will play a key role in shaping the modulation landscape for the next generation of wireless communication systems. Now let us see the conclusion. Modulation techniques play a crucial role in the evolution of wireless communication, influencing the efficiency, data rates, and overall performance of communication systems. Here are the key aspects highlighting the importance of modulation techniques in this evolution. Those are data transmission, data rates and spectral efficiency, spectral conservation, signal quality, and robustness. Adaptability to channel conditions, transition to higher generations, emerging technologies, future innovations. In summary, modulation techniques are fundamental to the evolution of wireless communication, driving advancements that empower higher data rates, spectral efficiency, adaptability to channel conditions, and the seamless transition to future generations of communication technologies. They are a critical enabler for the delivery of diverse services and applications in the rapidly evolving landscape of wireless communications. Thank you everyone for listening. If you like the video, please like, share and subscribe my YouTube channel. Thank you.